and welcome back to another episode of Math with Stone. Today, we are going to be doing the segment addition postulate to find out specific lengths of portions of lines. So what is the segment addition postulate? Well, in a simple way of putting it, a segment addition postulate is when you take any line segment and you break it up into pieces. So if I took this line segment and I broke it up into this three pieces right here, if I were to tell you that this point here were A and B and the last point is C, well, if I put together the line segment from A to B and I put together the line segment from then B to C, I would end up with the entire line A all the way to C, which means that we added segment addition postulate. We added two different line segments to get the whole thing. So officially it is, if we were to add AB, the first chunk, with the second chunk, BC, we would get the whole line segment A all the way to C. And you can use that idea to be able to solve a lot of things. For instance, if I told you that all the way from A to C was 12, and then I told you that this chunk from B to C was only 2, we could use either the formula, but in this case we could actually understand that, well, if the whole way across is 12, and this little part is 2, what would be A to B? Well, A to B, in order for this whole thing to be 12, would have to be 10. And that's because 10 and 2 make a total of 12. All right? And that's an easy way of doing it. But they do get a little more complicated, and that's what we're going to do next. So on this next problem, you'll notice that we don't have 2 sections. We actually have 1, 2, 3 sections, and that changes nothing. You can add multiple sections together and total it to equal the whole thing. So we have variables this time as well. If I were to take the first section, the second section, this middle section, and the third section, I add them all together, they would have to equal the whole thing. Well, the whole thing is 23. So if I were to add up x minus 6 and 9, first 2 sections, and I keep going and add up the 2x minus 19, that would have to equal the entire length of the line, which is 23. So we added up all 3 shorter sections to equal the whole thing from one end to the other. From here, you have to combine like terms and solve this equation. So we're going to combine our x's. We got x here, 2x there. We can combine those to make 3x. We have negative 6, positive 9, and negative 19. If I add negative 6 and positive 9, and then a negative 19, if I add all 3 of those together, we'd end up with positive 3 and then negative 19. That's negative 16 when we add all 3 of those numbers together, equals 23. Now it looks a little bit easier to solve because we've combined all our like terms. I'm going to have to just add 16. And I'd get 3x is equal to 39. And when I divide by 3, I get my answer as x equals 13. Now for some problems, they won't even give you a picture. And when you're not provided a picture for geometry, especially when in doubt, just draw it out. And that's what we're going to do here. There is going to be some information we're going to have to adhere to. And in this case, that is that point B is somewhere in between points A and C. That doesn't mean that it is perfectly in the middle. That just means it's somewhere in between it, okay? And we're also have to be told that A, B, and C are all on the same line, which is collinear on the same line. We're going to be finding X and AC. So I'm provided these bits of information about this collinear line segment, and if I know that point B is somewhere in between A and C, that's what I'm going to start out with. I'm going to draw a point A and a point C, and I'm going to put point B anywhere in between it. I might be right, I might be wrong, it might not be to scale, but it's somewhere in between A and C. Now that we have our picture, all we have to do is just label the parts that were provided. Well, A to C is 3x plus 3, so that means that all the way across this thing is a 3x plus 3 from A all the way to C. And A to B is a negative 1 and 2x, so from A to B, negative 1 plus 2x. And from B to C, BC is 11. We can put in the 11 there. Now it's just like the other problems because we have our picture drawn out. If we add the two smaller sections of this line segment, it would equal the whole thing from A to C. So if I were to add the negative 1 plus 2x and the 11, if I put these two parts together, it would have to equal the whole thing, the entire total, which is 3x plus 3. We still have to combine like terms, so I'm going to combine negative 1 and 11 to make 10. So I got 2x plus 10 equals 3x plus 3. Now you can move the x's either to the left or the right side of the equation, but in this case, I think it's a little easier to move the 2x over because it will remain positive. 3 minus 2 is 1x plus 3. And we're going to subtract 3 and find out that 1x is equal to 7, which really just means that x is equal to 7. So we found out x, but we still are required to find out the length of AC, and there are two different ways to do it. You can plug in x into the part that AC is equal to, right here, the 3x plus 3. So we could do that. AC is equal to whatever happens when we plug in 7 into 3x plus 3. So I'm going to plug in a 7 there, and then I would get my answer. So I plugged in a 7 here. 3 times 7 is 21 plus 3 makes 24. So AC would equal 24. Now that's not the only way you could do it. You could have also plugged in the 7 in for AB, and if we did that, we would have negative 1 plus 2 times 7. And when we get that answer, we end up with negative 1 plus 14, which is 13. Well, what happens when we add 13 for A to B and 11 for B to C? Well, 13 and 11 combine and you get the same 24. So either way you do it, you're still going to be able to get the right answer. So this next problem, we have a line segment, but instead of being told the total, we're told just different parts. So in this particular problem, I am going to start, not by finding HJ. I'm not going to be able to find out HJ right away, but I'm going to start by attempting to find what is the total length of this line segment from G all the way down to J. So the total length is actually going to be not incredibly hard to do. We can't add 2 and 12 together. That won't tell us the total because we'd be missing this chunk in the middle. We also can't add 2, 7, and 12 together because that we would have an issue there as well because this 2 is a part of, the 7. So there's actually a few different ways that you can do this. You can first start by recognizing that G to I and I to J, that would add in total make the entire thing. So if we see that this part is 7, and then the next part is 12, that would mean that 7 and 12 could be added together to get the total for G all the way to J. That's one thing we could have done. The other thing we could have done is we could have forgot that that was even there and just found the length of H to I. Well, H to I, if it's 2 right here and it's 7 from G all the way to I, we could figure out and deduce that that must mean that HI must be 5. And then we could have added the 2 and the 5 and the 12 and still got 19. None of which is actually what we're expecting to find. We're actually asked to find what is H to J. Well, here we have an H and there we have the J. How much is it from H all the way to J? That would be 5 and 12 put together. Well, what is 5 plus 12? That would be 17. So that means that HJ is apparently 17 units long. That's going to be doing it for today's episode. Until next time, stay positive, and I will see everybody later. Bye.